this problem, this is problem number 4 in paper 2, has to do with remainder theorem. We've done a little bit with remainder theorem. What they're saying is if you took this function 4x cubed plus 2x ax minus 7a, is it factored? Is it factorable? Did it factor out nice? No, unfortunately not. When you put an a in, here, you're going to get negative 10 for a remainder. So that's why you put in the value for x. In this case, if you have x minus a, what's the value you put in for x? We're going to let the value that makes this 0, x equal to a, right? So put an a in for x. You're going to get 4 times a cubed plus 2a times a minus 7a, move the 10, plus 10 equals 0. And so you're going to get 4a cubed plus 2a squared minus 7a plus 10 equal to 0. Is that all right? I put the a in for x, and I moved everything to one side. So the remainder theorem says that if you put the root, which is a, into the factor, it should be equal to 0. So that's how I get x equal to a. So I put that a in, and I get this. Now, because they're saying that the remainder was negative 10. That's the remainder theorem. You put in that value in. If it is 0, it factors out. If it isn't factoring out, you get the remainder out here. Now what we want to do, we're going to find the value for a that makes this work. Well, the value for a that makes this work, you're going to have to either do trial and error or dun, 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 synthetic. So should we try it? Well, you're going to want to see which one works. So you got to try some things. You got a lot of things to try. I always try 1, but obviously 4 plus 2 is 6, plus 10 is 16 minus 7. 1 isn't going to work. Yeah, you have the calculator here. Sure. Yeah, do that. But I think it's negative 2. Drop the 4 down, negative 8, negative 6, 12. 12 minus 7 is 5. 5 times negative 2 is negative 10, 0. That means that x plus 2 times 4x squared minus 6x plus 5 is the factoring out of that. And the a that's going to work is going to be negative 2. You can use your calculator, though, for sure. Then show for this value of a, there is a unique real solution for f of x is equal to 0. So what they mean by unique solution is that, I think it does this, right? Does that sound right? It touches it. And that every, no, not that. It's going to hit the graph once. And it never comes back and crosses the axis again. So what would the roots of this look like? If this is a unique solution, here is your a. In order to be unique, these can't have roots, so the roots must be imaginary. Right? So if we could prove that these roots are imaginary, we'd prove that this is unique. So let's factor it. Minus b plus or minus square root b squared minus 4 times a times c all over 2a. And this will be 6 plus or minus the square root of, what's 36 minus 80? minus 44. Is this going to be real or imaginary? That negative. Imaginary. So no roots are going to come out of this. This is going to be a single, what do they call it? Unique real solution. Therefore, since all other roots are imaginary, then A equal negative 2 is a unique root. And you know how to find unique roots? Unique up on them? What a great way to